Hello, Keith Rucker here at VintageMachinery.org. Guys, I'm out at the museum today, and mainly because I need to borrow the big Old Faithful Elijah Shipley lathe here for a little project I got going on. I've got to cut some left-hand threads. I've got an issue on my LeBlanc lathe at home. It works just great, but for some reason I'm having difficulty getting the carriage where I can do left-hand work. So basically reversing the direction of my spindle speed or whatever on my feeds and my threading. So anyway, we're out here, we're going to use this lathe today. So the project for the day is I need to make a new little piece here, and this is actually a project that was sent in by a viewer, AJ Kolodinsky. And AJ, I apologize if I didn't pronounce that right, and I probably didn't. But anyway, this is a piece off of a blacksmith's post drill. So if you've ever seen a post drill, it's basically a hand cranked drill that would have been in an old blacksmith shop that has a mechanism in it that feeds down as you're doing it. There's a little cam operation. But this is the rod that goes in the top, and as you feed that, there's a little hand wheel on here that turns this, and that's what feeds the drill down. And his is broken. So we're going to make this new piece. Let me take you over to the bench, show you the part. I've got a little quick drawing, and we'll get over here and get this thing made. So here again is the part, and it's 7 3/4 inch long, 1.1 in diameter, and we've got a 7 threads per inch left-hand thread that goes down this thing. And that's what we're going to be working on the lathe to get done. So AJ sent along this piece of stock here. This is actually some thick wall tubing, which this is tubing, as you can see as well. The inside diameter is pretty much right in line with what we got here. So I think there's maybe some clearance that's needed in there for something. I'm not exactly sure. But anyway, pretty simple project here. I've got a little sketch here of what we got to do with my critical dimensions on here. So first thing we're going to have to do is this piece is a little bit oversized, so it is 1.25 inches. So we basically have to take 1/8 of an inch off of it, turn that off, and then come in here. We have to cut our left-hand threads on here, and once that's done, I'll take it back home and put it in the mill machine and cut the keyway. Should be a fairly easy project to make, and I probably just cursed myself by saying that. But let's get set up over here on the lathe and see if we can get this thing knocked out. I'm going to start out by chucking this up pretty close to the chuck itself just to give some support. I'm going to finish this in, so we're going to face this off just to get a nice end. And then what I want to do is I want to come in here with a tool to get up in here and actually cut a nice center in there, 60-degree center, where it's running true. This inside of this tube it's basically been extruded, and it's probably not running perfectly true. So the idea is to actually get that surface running true, that I can come in and put a live center in this, because when we extend this out on the lathe, we're going to want some added support down there on the end. So that's the project right now. Let's start by facing that off. All right, we're going to come in here, touch off, and just go down that little bit. Clean up that edge. All right, that's done. All right, I got my compound set to 60 degrees, and I got a tool that I can get up in there and cut that out with. So I basically just want to get a little bit of the surface in there, cut to that angle all the way through, just enough to get a center to run on. And that actually should do it right there. I think we're ready to get started here. I got my part set up again. We're in the chuck. This is on a regular scroll chuck. I didn't bother indicating it in. We're going to be turning the whole thing to diameter, so it's going to true itself up. Down here on the end, we got a live center in our part, centered up pretty much on the part like it was. So we're good to go. That should give us plenty of support. Got my cutter in here, and goal right now is get this turned down to 1.1 inches, so that's 1.125. We got about 125 thousandths to take off of it roughly, and take it down to that depth. So let's do it. Getting no nasty stringy chip. I hate these things when it cuts like this. I'm going to see if I can still see my line down there. We're going to try to get through this, and maybe once we get that outer coat off of this extruded piece, it won't be quite so bad. We're going to make our second pass here, and I'm going to take a lighter cut this time, just trying to cut down that stringiness of the chip. Material is not one to cooperate. They have just a little bit of a taper going on. See, that's about 157 and a half. That's about the same. It's within a thou. That's close enough for what we're doing. So anyway, nibble it on out. Well, that 15 thousandths chip at least isn't curling up around it as bad. Still kind of stringy. It sure isn't taking a whole lot of material off. I don't know what material this is, but it's kind of a gummy, stringy stuff, whatever it is. Right on the money. That's right where we need to be. Yep. All right, guys. I've got my threading tool in here, and one of the things you always need to do when you're threading is get the height of this tool basically right in the center of your part. And that's sometimes difficult to do, so I'm going to use a little tool here. This is a little tool just to do that, to get your tool on center. This is made by Edge Technologies. Had this for a while. You come up here underneath it and put this edge on the cutter. You got a little V on this side that you just kind of put tension up here like such, and there's a level in the top. And what I'm going to do is just now screw my tool holder up until the bubble reads level, and when it does, we should be right on center. Lock that in place, and we should be good to go. Thought I'd share that little tool. So I think I'm about ready to start threading here. I've got my RPM set on 136 RPMs. Should have my dial over there set for 7 threads per inch. We're going to do a check on that here in just a second. Let me go ahead and feed until I'm just touching so that we can do a scratch test here. There we go. Wait for a number to come around on my dial. There we go. Getting my pitch gauge here and verify, yes, we are on 7 threads per inch, and we are cutting in the left-hand direction. All right, let me zoom you out here where you can kind of see what's going on. We're ready to go ahead and start making our passes here. Just a couple of comments. I've got an indicator set up as a depth gauge here, and I like setting it up where it's on the tool post because I'm going to feed in at the angle, which we have our compound set opposite of backwards because we're going to be cutting in this direction. So we got our compound set at 29.5 degrees going in this direction, and this is going to give me a true reading on how deep I am. Because I'm feeding at an angle, if I just use the scale, it's not going to give me an accurate number because because I'm on the hypotenuse of a triangle, I'm going to be turning this more thousandths on the dial than what's going to read going straight in. And I know how far. For 7 threads per inch, I need to feed in 93 thousandths. So this right here will kind of help me watch what's going on and know when I get down close. Other thing, my thread dial down here. This is what I use to time when I engage my feed so that my threads all match up. And because we're doing an odd number of threads, I have to start on any numbered line. Now, if you're doing even threads, you can start on any line on here. It doesn't matter. But for odd threads, you start on any numbered line. And you need to look on your lathe to see how it is. That's how most lathes are. But some can be a little bit quirky when it comes to which line you need to line up on. And if you're ever in doubt, just always start on the same number every time, and you can't go wrong. But we can start on any numbered line down here. All right, so we are ready to go. Let me get a little lube on here. I need a new brush. My brush is showing some wear here. I'm gonna feed in on the cross slide, and we're gonna probably start with about a 10/1000ths cut. And we'll wait for a number to come around over here. There goes 2. I'm gonna wait for 1 to come up, and we'll engage. And away we go. Stop. And I'm going to back out now. I'm going to use my cross slide. I'm not using the compound, I'm using the cross slide. And I got a 0 mark on the cross slide where I can go back to. We'll come back in, come to our starting point. I'm going to go back to 0 on my cross dial, and we'll feed in another 10/1000ths. Wait for our numbered line to come around, and then wait for 6. Left-hand threads are a little less worrisome because it's hard. You're not going to crash into the headstock. Of course, if you don't stop, you can crash into your live center down here, but you got a little bit more room to get stopped down here when you're doing left-hand threads. Back to 0. Take another 10. Little word here about the way we're feeding in. So again, we're coming in at this angle, which is half of your 60 degrees, 30 degrees. Most books will say 29.5. It really doesn't matter. But as you're feeding in, when you do this, you're always feeding in at that same angle as the back edge of that cutter. And your entire cut is on the face of it. So as you go deeper, your cut is getting wider and wider and wider. So as you get deeper, you're going to have to take smaller cuts because of that. The first couple of passes, I probably honestly could have taken, 25 thousandths on that first pass, wouldn't have mattered. Now, some people will tell you that with carbide tooling, you don't have to set your angle. You can just go straight in. And I can't disagree with them because I see people doing that and it works. This is the old school way of doing it. This is the way the old books say to do it. I like this method better. I just feel uncomfortable going straight in because when you do, you're technically, as that cut's moving across, you could be taking a little bit of cut on the back side of that cutter, and you're not moving toward the cut. You're moving away from the cut when you do that. And I don't know if that can make a difference or not, but this way I know I'm always moving forward into my cut. So that's just the way I like doing it. If you like doing it a different way, go for it. Not going to hurt my feelings. But this is the way I've always done it. This is the way I'm going to keep on doing it. We'll go ahead and take another 10, and then after that we're probably going to start taking 5 thousandths cuts. According to the book, we should go to 93 thousandths on the depth to be at a perfect thread pitch. I've got the part that screws up on this, but because it's so old and it may be worn, I'm gonna probably just have to make this thing fit. So I'm gonna stop at 90. We're gonna go do a test fit, and from there on out, it's just gonna be, we're gonna cut it to where it fits. But I'm concerned that it may need to be a little bit larger than normal just because of the wear that's that could be in that little piece that it goes onto. So we'll make a test fit after this cut. Let's see what we got. So this is left-hand thread, so it's backwards than normal. You want to, instead of righty-tighty, lefty-loosey, it's going to be righty-loosey, lefty-tighty. Yeah, I don't know. We're going to go this way. And it is threading on there very nicely. A little bit of slop in it. It's not bad, though. I think that's actually going to be just fine. If I had my druthers, I probably should have stopped a little bit sooner than I did. I didn't think it was going to be that worn, but I think that's going to be fine. But there we go. Left hand, 7 thread per inch threads. Last step on the lathe here, we just need to face off this other side. I cut it off on the bandsaw. We just flipped it around. This is a rough sawn cut, and just make that nice and smooth. We will come right in here and hit that and take care of it. Now just hit it with a file here. Deburr. All right, lathe work is done. We have the new part roughed out here. It looks great. Missing 2 features from the original. Number 1, we got to come in here and cut the keyway, and we'll do that at home on the mill machine. The second feature we don't have on the new one is this detachable section in the middle, but we're going to leave that part out of the new design, I think. Last step here is cutting that keyway, and for that I've come back home to the home shop, and we're going to use the old K&T horizontal milling machine for this. So again, let me zoom you in here, show you what we're doing, show you why I'm using this machine rather than my vertical mill, and we'll get this thing cut. This is again the original part with the unusual feature in the middle there that we're trying to get away from. But if you look at this, it's a 1/4 inch keyway cut all the way down to right about here. But the reason I'm doing this on the horizontal mill is if you look down here at the end, it comes up in an angle out of the bottom of this. And this was obviously cut using a wheel cutter on a horizontal mill. Now, I could easily go do this on the vertical mill, but when you do that, you end up with a slot that's all the way down here, and you end up with a round surface in the back because you're using an end mill. At the end of the day, from a functionality standpoint, it doesn't matter. Either one works just fine. But because this is an antique machine that AJ is trying to restore, when I'm doing a restoration, I always try very hard when I make a new part to make my machine marks look like the originals whenever possible. So this is just one of those little detail features that at the end of the day, it really doesn't matter as far as functionality goes, but from an aesthetic standpoint, this part that I'm making is going to look just like the original part. And for me, that's important. For others, they could probably care less. But that's the reason I'm doing this on the horizontal mill. Now, as far as cutting keys on the horizontal mill, keyways on the horizontal mill versus the vertical mill, I actually prefer the horizontal mill over the vertical mill. That's just a personal preference. The amount of setup time, it's really not that much difference. And I can just, a lot of times, get it done faster on the horizontal mill anyway. Now, let's look at my setup here. I've shown setting up how to use a horizontal mill to do this kind of stuff time and time again, so I didn't take the time to do that in this video. Lots of my older videos show how to do that. But real briefly, we just got a 1-inch arbor in here. I've got my wheel cutter on here. This is a 1/4 inch diameter. This is a regrind that I found over there in my bin full of cutters. This one's been freshly sharpened, so it should be in good shape and ready to go. Now, as far as holding down my material on this, I'm not using a vise. We're just got it clamped straight down to the table. This is a little trick that's real handy. Anytime you're doing shaft work and you need to cut a keyway or something like that, you can just come over here and use one of these key slots or T-slots in your table. You can do this on either a horizontal or a vertical mill. Just clamp it right down in there where that round stock fits in that groove. Now these grooves, as long as your machine is in halfway decent shape, they should be running, you know, parallel with the machine. So the nice thing about this is I can just go clamp this thing down to the table and not have to worry about getting the indicator out like if I have a vise and getting everything lined up. This should be dead nuts on. It's just quick and easy. Now on this part, number one, it's relatively short. I'm going to be cutting on the end. So work holding was a little bit of an issue here. You know, I could have put this in a vise, but I wanted to use a trick here. To hold down, the way I'm doing this is I actually took a piece of metal, because this is hollow, I just took a piece of round stock, I ran through there, and I'm actually clamping down on this piece of metal, which is then pushing that down into the T-slots. If it was a keyway that I had room on either side, you know, I could just clamp right on the top of this, but because of the confined space that I'm in, this right here is going to do the trick. So anyway, we're set up. I'm going to real quickly get my cutter set up, centered on the shaft. And again, I've done that in other videos. I'm not going to show how to do that here, but we'll just go through there and cut that keyway. Should be able to do it in one pass right down through there. All right, I got my part centered up on there. I've got my depth dialed in, which is 1/8 of an inch, 125 thousandths. Everything's locked down, so we should be ready to make. We're going to do this in one pass. I have my speed of my spindle set to 93 RPMs, which I got off of my feed and speed calculator for high-speed steel cutting on mild steel using this 3-inch diameter cutter. So that's actually just a tad bit on the slow side, but the next setting was a little bit over, and I'd rather be conservative on this, so that's what we're going with. As far as my feed rate goes, because of the number of teeth on the cutter, I should be able to zip through this pretty quick. I'm going to start out at 1 3/4 per inch. I mean, I should theoretically be able to run this thing at like, I don't know, I can't remember, it's like 8 or 9 inches per minute, but we're going to again, start out conservative, and I like to see how things sound and feel. So let's kick our mill into feed mode here, and we'll go from there. I think we're just going to let it cut. I'm not in a hurry. We could probably go faster, but again, we're not in a hurry. So we'll just let it roll through there. As is almost always the case with these wheel cutters on these mills, seems like a couple of the teeth are doing most of the work. It's just hard to find a spindle that's perfectly true unless you buy a brand new one, and all the ones I have are old used ones, but it really doesn't affect the quality. You know, when it's happening this way, you do need to slow your feed rate down a little bit, because normally you would want every tooth to be making the same cut, and this is acting not so much like a single tooth cutter, but it's probably about 3 or 4 of those teeth that are really doing the work. But that's just the nature of horizontal milling, at least using, again, the arbors that I tend to have laying around here. Got a mark on here for where I need to stop at. And that's about it right there. All right, keyway should be cut. Mission accomplished, guys. We got our part made. Everything's a good fit. Everything looks good. So let me zoom in and show you the final product, and we'll get this thing ready to ship out. Here we go. Looks like an acceptable facsimile of the original, minus the little feature there that we're trying to avoid. So anyway, like I said, we're going to get this packed up and sent back. Everything looks good, so I think this is going to serve him well. So AJ, I hope that suits you well. I hope it gets the job done for you. I think it will. And by the way, I went back and looked at the note that AJ had sent me that I should have read before I started shooting this, and he actually gave me the correct pronunciation of his name. It's AJ Kolechki. I think that's right. I can't remember how I said it when I was shooting the intro, but anyway, I apologize again if I mispronounced that earlier. But AJ, there you go. One drill press adjustment screw on its way back to you, and with that, that'll be a wrap. Thanks for watching, guys. As always, leave me some comments, leave me a thumbs up on the video, and if you haven't already, please subscribe to the channel. We'll talk to you later.